Take a deep breath. Let your shoulders loosen, and allow your mind to drift into the soft, endless dark of the universe. Tonight, we travel into something invisible, something gentle, something present in every corner of reality: the quiet, electromagnetic field. Before we move forward, imagine the universe not as empty space, but as a calm ocean of unseen waves. Waves that travel through stars, through planets, through the space between galaxies, and even through you. These waves, these soft ripples in space, are older than life, older than worlds, older than the first spark that lit the universe. The electromagnetic field is the silent thread that ties everything together. As you breathe slowly, imagine you're floating in this field, supported, held, connected. No tension, no pressure, just the steady hum of the universe around you. And now, let's begin our journey through it. Most people imagine space as a cold, empty void, a place without sound, without feeling, without motion. But the truth is far more magical. Space is alive with quiet energy, stretching from the smallest atom to the largest galaxy cluster. The electromagnetic field fills every point, every moment, every breath of the cosmos. It is the field that carries light. It is the field that lets the sun warm your skin from 150 million kilometers away. It is the field that allows stars to shine for billions of years. And all of this happens in silence, soft waves moving through an invisible ocean. Every radio wave, every beam of starlight, every color you see, every spark in your brain is a gentle vibration in this one universal field. Close your eyes for a moment. Imagine you can feel these waves. Soft, slow, drifting through the universe like whispers. You are floating in the same field that carries light from the beginning of time. A field so quiet, yet so powerful, that without it, the universe would be dark and lifeless. To understand this quiet field, we go back, far back, to the moment the universe began. Before galaxies, before atoms, before anything had form. Right after the Big Bang, the universe was pure energy, hot, dense, and chaotic. But as it expanded and cooled, something remarkable happened. The fundamental forces began to separate, like colors splitting from a bright white light. Gravity fell into place, the strong force began binding particles, and then the electromagnetic field emerged, one of the most elegant structures the universe would ever create. At first, the field was wild and powerful, rippling through a newborn cosmos filled with charged particles. As the universe cooled even more, these particles began forming atoms, and through them, the electromagnetic field shaped the first light, the first stars, the first structures of everything we know. It became the architect of the cosmos, the sculptor of galaxies, the painter of colors, the invisible engineer behind the formation of matter itself. It continues today, quietly, faithfully, everywhere. Even now, as you lie still, the electromagnetic field passes gently through your body, through your room, through the earth, through every star you've ever imagined. A field woven into the entire universe. To understand the universe, you must understand this one idea. An electromagnetic field is created whenever there is an electric charge, motion of that charge, or a changing electric or magnetic force. In simple words, electric fields come from charges, magnetic fields come from movement, and together they create waves that travel through space. These waves are not objects,
They are not particles you can hold. They are vibrations in the very fabric of reality. Every time a charged particle wiggles, even a tiny bit, it sends out a ripple in the electromagnetic field. These ripples can travel across the universe for billions of years without losing direction, without slowing down, without needing air or matter. That is why starlight reaches you, why galaxies glow, why your brain works, why your phone works, why everything alive communicates, all because of this single field. And the most beautiful part? It is everywhere, even in complete darkness, even in empty space, even in silence. The field never turns off. Everyone knows what light is, but not everyone knows what light truly represents. Light is simply a tiny part of the electromagnetic spectrum, the little slice that our eyes evolved to detect. Your eyes can see wavelengths between about 400 and 700 nanometers. But beyond that, the universe is filled with invisible waves. Radio waves, longer than mountains. Microwaves, gentle heating waves. Infrared, warmth itself. Ultraviolet, the invisible glow of stars. X-rays, sharp penetrating waves from cosmic explosions. Gamma rays, the universe's most powerful energy bursts. All of these are the same thing: electromagnetic waves vibrating at different frequencies. The only difference between a soft radio wave drifting through space and an energetic gamma ray from a dying star is how fast it vibrates. Nothing else. Imagine the universe as a symphony. Every wave, slow or fast, is a different note. Together, they create the music of the cosmos. And in that quiet cosmic music, light is just one gentle sound among billions. The universe is not held together by hands or strings. It is held together by forces. And the electromagnetic force is the sculptor of almost everything solid. Here's how. 1. Atoms exist because of electromagnetism. Electrons don't crash into the nucleus because they are guided and balanced by EM forces. Without this field, atoms collapse, matter disappears, the universe becomes chaos. 2. Chemistry exists because of electromagnetism. Every bond, every reaction, every molecule is controlled by electromagnetic attraction and repulsion. Water, DNA, oxygen, stars, all shaped by this one invisible field. 3. Your body communicates through EM signals. Your heart beats because electrical impulses travel through cardiac cells. Your brain works because billions of tiny electrical signals fire every second. Even your thoughts are tiny patterns in the field. 4. Stars and galaxies form under its influence. Magnetic fields twist inside newborn stars, guiding their rotation. Galaxies carry enormous magnetic tendrils stretching over thousands of light years. The electromagnetic field doesn't just live inside atoms, it stretches across space on unimaginable scales. It is the universe's quiet architecture, the blueprint behind the shape of everything. Most people think of the electromagnetic field as waves in space, but modern physics goes deeper, down to the quantum fabric underneath everything. In quantum field theory, the electromagnetic field is not a wave floating through space, it is space. It is a fundamental field that exists even when nothing else does. A calm way to imagine this: beneath every atom, beneath every vacuum, beneath every galaxy, the electromagnetic field is present as the U1 gauge field, the simplest and most elegant of nature's fundamental fields. Reference, Standard Model of Particle Physics. When this field vibrates with the smallest possible excitation, it creates a photon, the quantum of light. not a particle in the classical sense, but a tiny packet of the EM field's energy. Even in complete darkness, the field never drops to zero. There are always fluctuations, tiny jittering motions called quantum fluctuations. Reference Casimir experiments. Your universe is never truly empty. It hums quietly with constant quantum activity. This is the deeper truth of the quiet electromagnetic field. It is a quantum ocean, gently vibrating even when nothing seems to move. Before quantum mechanics, a Scottish physicist, James Clerk Maxwell, discovered something extraordinary. He wrote 4 equations, just 4, and those 4 equations revealed how electric fields behave, how magnetic fields behave, and how the two create waves that travel at the speed of light. Maxwell didn't know it then, but by solving his own equations, he discovered that light is an electromagnetic wave. In calm terms, Maxwell's equations are the universe's instruction manual for how light moves. Here's the advanced idea, but explained softly. Gauss's law: electric charges create electric fields. Gauss's law for magnetism: magnetic fields have no isolated charges, no magnetic monopoles detected. Faraday's law: changing magnetic fields create electric fields. Ampere-Maxwell law: changing electric fields create magnetic fields. These 4 simple rules produce everything from radio waves to gamma rays. They're the cosmic sheet music. Every star, galaxy, and atom plays by these rules. Reference J.C. Maxwell on Physical Lines of Force, 1861. Even now, as you rest, the world around you runs on these equations. Your heartbeat, your phone signal, the light from distant galaxies, all expressions of the same elegant field dynamics.
Now we move farther into astrophysics, where electromagnetism shapes colossal structures. Space is not an empty void. It's filled with plasma, the 4th state of matter, a soup of charged particles that respond strongly to electromagnetic fields. Because plasma fills more than 99% of the visible universe, reference NASA Heliophysics Division, electromagnetic forces dominate cosmic scale behavior. And this is where things get truly advanced and fascinating. 1. Galactic magnetic fields. Every galaxy, including the Milky Way, has magnetic fields stretching tens of thousands of light years. These fields guide star formation, influence galactic rotation, help shape spiral arms, control how cosmic rays travel. They act like an invisible skeleton inside each galaxy. 2. Magnetohydrodynamics, or MHD. This is the physics of how magnetic fields interact with cosmic plasma. It explains solar flares, auroras, star formation jets, black hole accretion flows, interstellar turbulence. NASA, ESA, and multiple astrophysics journals use MHD to model cosmic behavior. And 3. Magnetic fields around black holes. Even though black holes trap light, the space around them is flooded with electromagnetic chaos. Their rotating plasma disks twist magnetic fields so violently that they launch relativistic jets, beams of electromagnetic energy that can stretch thousands of light years. These jets can influence entire galaxies. Reference Event Horizon Telescope studies of M87. Even at cosmic scales, the quiet electromagnetic field is never truly quiet. It structures the universe like invisible architecture. The human brain is often described as electrical, but the real story is far more sophisticated. Neurons communicate using electrochemical gradients, ions flowing in and out of tiny channels. Each time a neuron fires, it creates a small electric field, and when many neurons fire together, their fields overlap and form measurable electromagnetic patterns. These patterns are known as brain waves or neural oscillations. 1. Correct neuroscience,
brainwave frequencies. These oscillations are extremely well studied, reference EEG literature. Delta waves, 0.5 to 4 Hz, deep sleep. Theta waves, 4 to 8 Hz, drowsiness, early sleep. Alpha waves, 8 to 12 Hz, calm wakefulness. Beta waves, 12 to 30 Hz, thinking and focus. Gamma waves, 30 to 100 Hz, high-level processing. These are not energy vibrations in a mystical sense. They are real electromagnetic fields generated by synchronized neuron firing. 2. Brain EM fields coordinate thought. Neuroscientists describe this using EM field theory of consciousness, reference McFadden and Pocket, Cognitive Neuroscience. The idea is simple. When billions of neurons fire in rhythm, their combined electromagnetic field can influence nearby neurons, strengthening certain circuits and allowing complex thoughts to form. This is not speculation. It is supported by transcranial magnetic stimulation, magnetoencephalography, and neural coherence studies. Even as you lie still now, your brain produces a quiet electromagnetic signature, a field shaped by your thoughts, your memories, your dreams. Now we move from the human brain to the entire planet. Earth is surrounded by a vast electromagnetic structure called the magnetosphere, generated by the motion of molten iron in its outer core. This is known as the geodynamo, reference U.S. Geological Survey, NASA Goddard Space Flight Center. The magnetosphere shields Earth from the solar wind, prevents the atmosphere from being stripped away, enables auroras, shapes radiation belts, protects life from cosmic radiation. The sun constantly releases charged particles at 300 to 800 kilometers per second. When this plasma hits Earth's magnetic field, it compresses the daytime side and stretches the night side into a long magnetic tail called the magnetotail. This interaction produces geomagnetic storms and lights up polar skies with auroras. Earth's upper atmosphere becomes ionized by solar radiation, forming the ionosphere, a layer that reflects radio waves and enables long-distance communication. The ionosphere vibrates with Schumann resonances, global EM waves around 7.83 Hz, caused by lightning around the world. These resonances are real, measurable, and stable across decades. Reference Schumann, 1852. Earth's surface, atmosphere, and magnetic field combine into a dynamic EM environment. Lightning generates electromagnetic pulses. The magnetosphere traps charged particles. Solar storms inject high-energy plasma. Ionospheric currents create global circuits. You live inside a gigantic electromagnetic cocoon that has protected life for billions of years. To understand the field at the deepest level, we go back to the early universe, just minutes after the Big Bang. This part is pure cosmology, supported by observational data. 1. Primordial light, the cosmic microwave background, or CMB. The CMB is the oldest electromagnetic radiation in existence, 13.8 billion years old, detected by COBE, WMAP, and Planck missions. It is not just a picture of the early universe, it contains polarization patterns. These patterns reveal density fluctuations, early plasma behavior, and potential primordial magnetic fields. Reference Planck collaboration, CMB polarization studies. 2. Plasma epoch. For just under 380,000 years after the Big Bang, the universe was a dense ionized plasma. EM fields controlled how matter moved because plasma responds strongly to electromagnetism. This is supported by baryon acoustic oscillations, recombination modeling, and plasma cosmology equations. In this era, EM waves shaped the distribution of matter long before stars even formed. 3. Primordial magnetic fields. Several modern cosmology papers suggest that weak magnetic fields may have formed immediately after the Big Bang due to phase transitions, inflationary quantum fluctuations, turbulence in early plasma. These fields could have seeded the large-scale cosmic magnetism we observe today. Reference Subramanian 2016 Annual Review of Astronomy and Astrophysics. 4. Electromagnetism as one of the earliest structured forces. Within the first trillionth of a second, forces separated from the unified field. The electroweak force split into the weak nuclear force and the electromagnetic force. This is well supported by particle physics. Reference electroweak unification, Glasgow-Weinberg model. From that moment on, light became possible. Atoms became possible. Stars became possible. Life became possible.
The universe on the largest scales looks like a web, an intricate lattice of filaments, sheets, and voids. These filaments are not made of solid matter. They are enormous rivers of plasma, ionized gas whose charged particles respond strongly to electromagnetic forces. Because plasma dominates the visible universe, electromagnetic fields are not a small perturbation. They are a main player in how structure forms and evolves on cosmic scales. Think of a cosmic filament as a slow-moving, almost unimaginably vast current. Within it, weak seed magnetic fields, perhaps produced during inflation, phase transitions, or early plasma turbulence, are stretched and amplified by the motions of gas and galaxies. Over cosmic time, these fields can reach strengths that influence gas cooling, heat transport, and the formation of galaxies inside the filament. Observations and simulations now show magnetic fields threading the cosmic web, although measuring their exact strength and origin remains an active research frontier. The key physics is magnetohydrodynamics, MHD, the set of equations that couple fluid motion, hydrodynamics, with magnetic fields. In MHD, magnetic field lines are often frozen into the plasma. They move and twist with the flow, transferring angular momentum, guiding charged particles, and enabling long-range organization of structure. This is how relatively tiny initial magnetic seeds can become the vast, coherent fields that help shape the cosmic web's skeleton. Even a quiet electromagnetic field can store enormous energy. In plasmas, magnetic fields can be twisted into tight configurations over time. When field lines of opposite direction are forced together, the topology can change in a single dramatic event, magnetic reconnection. During reconnection, magnetic energy is rapidly converted into particle kinetic energy, heat, and high-energy radiation. This process powers solar flares, auroral substorms, coronal mass ejections, and many of the most explosive events in the universe. Reconnection has both macroscopic and microscopic aspects. On large scales, MHD describes how current sheets form and collapse. On small scales, collisionless physics and kinetic processes determine how electrons and ions are heated and accelerated. Recent satellite missions and laboratory experiments have tightened our understanding of how reconnection accelerates particles and redistributes energy, insights that apply from the sun to the magnetized winds near black holes. For your sleep mind, imagine magnetic field lines as invisible rubber bands in slow motion. Over time, they get stretched and knotted by plasma flows. Then, in a whisper or a crash, depending on scale, they snap and reconnect, releasing stored tension as a burst of light, heat, and fast particles. Even the quietest field harbors the possibility of sudden, beautiful violence. Now we enter the extreme lab of nature, neutron stars and magnetars. These are compact remnants of massive stars, objects the size of a city but with masses greater than the sun. Their magnetic fields are among the strongest known. Typical pulsars have surface fields around 10 to the 8th to 10 to the 13th Gauss, while magnetars reach 10 to the 14th to 10 to the 15th Gauss or more. These fields are so intense that they change atomic structure, affect vacuum polarization, and enable exotic quantum electrodynamic effects, QED effects. The magnetosphere of a rotating neutron star is a region filled with relativistic plasma and strong electric fields. The rotation and intense magnetism produce electric currents, pair production cascades, electron-positron creation, and the emission of pulsed radio to gamma-ray radiation. Modern theoretical and numerical models, including force-free and MHD approaches, aim to reproduce observed pulse profiles, spin-down rates, and high-energy spectra.
These magnetospheres are dynamic. Currents twist, magnetic reconnection can occur, and particle winds flow outward into pulsar wind nebulae. Magnetars take these effects to the extreme. Their decay of ultra-strong magnetic fields can power giant flares and repeat bursts of X-rays and soft gamma rays. The internal magnetic stresses may fracture the crust, driving sudden rearrangements of the external field, events observed as short, luminous flashes. The physics here touches on general relativity, nuclear matter, supernuclear densities, and QED in strong fields, a synthesis of disciplines where electromagnetism and gravity meet at the edge. Electromagnetic fields may be invisible, but the universe leaves clues, faint fingerprints, showing their presence across billions of light years. Scientists use multiple methods to study cosmic magnetism. Each one is delicate, elegant, and based on real physics. 1. Faraday rotation. When polarized light passes through a magnetized plasma, its angle of polarization slowly rotates. The amount of rotation tells us the magnetic field strength, the density of the plasma, and the distance the light traveled. This is how we map magnetic fields in galaxies, clusters, and even in the cosmic web. 2. Synchrotron radiation. When electrons spiral around magnetic field lines at nearly the speed of light, they emit synchrotron radiation, a kind of polarized radio glow. We detect this glow with large radio telescopes, LOFAR, VLA, MeerKAT, SKA under construction. The intensity and angle of the radiation reveal the geometry of magnetic fields. 3. Zeeman splitting. Strong magnetic fields, like in star-forming regions, split atomic spectral lines into multiple components. This lets us measure magnetic fields inside gas clouds where stars are being born. The cosmic microwave background, the oldest light, carries polarization signals that may reflect primordial magnetic fields. This is how we probe magnetism from before galaxies existed. These tools allow us to map an invisible architecture, a magnetic framework stretching from molecular clouds to entire galaxy clusters. Now we go even deeper, to the marriage of electromagnetism and gravity. Maxwell's equations are perfect in flat space, but the universe is not flat. Mass curves spacetime, and curved spacetime alters electromagnetic fields. In general relativity, Maxwell's equations become nabla A FAB equals mu0 JB and nabla A star FAB equals 0. You don't need the math, just the meaning. 1. Light bends in gravity. Light follows curved spacetime, so electromagnetic waves bend near stars and black holes. Reference gravitational lensing. 2. Magnetic fields twist around rotating masses. Near rotating black holes, Kerr spacetime, magnetic field lines become twisted and dragged. This process helps launch relativistic jets. Reference Blandford's Nyack mechanism.
3. Electromagnetic energy contributes to space-time curvature. Gravity and electromagnetism interact. Strong magnetic fields have energy density, and energy curves spacetime. Reference Einstein-Maxwell solutions. 4. Neutron star magnetospheres in GR. Modern models use general relativistic MHD to simulate how magnetic fields behave near compact objects. This is essential to understanding pulsar wind nebulae, magnetars, and accretion disks around black holes. Reference GRMHD simulations. Think of it gently. Gravity molds the stage, but electromagnetism lights it. Now we step from cosmic scales into the fragile architecture of life. The human body is an electromagnetic creature, but it is also delicate with strict boundaries. 1. The brain's EM field is real, but small. The brain's field is measurable, but extremely weak, about a picotesla at the surface of the skull. For comparison, Earth's magnetic field is billions of times stronger. This is why external natural EM fields don't disrupt thoughts or memories. Reference MEG studies, neural field measurements. 2. Action potentials are ion flows, not pure electricity. Neurons encode information using ion gradients, voltage-gated channels, and millisecond spikes. All of this produces local electric fields, but these are biological, not technological. Reference: Hodgkin-Huxley model. 3. Electromagnetic fields inside the heart. Each heartbeat is triggered by the sinoatrial node, which generates a coordinated electrical impulse. This creates a detectable electromagnetic field, the basis of the ECG. Reference: Cardiac electrophysiology. 4. Weak EM about the body is normal. Muscles, nerves, and tissues generate small EM signals. They are part of healthy function. There is no evidence that natural EM fields from Earth or space harm the body. Reference: WHO EMF reviews, biophysical limits. 5. Strong EM fields have thresholds. Only extremely strong EM fields, far above anything in natural environments, can affect biology in harmful ways. Reference: ICNHRP safety guidelines. So even as you lie still now, your body is humming quietly with microscopic electromagnetic signals, the dance of life at the cellular scale. Even the birth of stars is guided by invisible forces. Interstellar clouds are made of plasma, dust, and gas, often spanning dozens of light years. Electromagnetic fields within these clouds play a crucial role in preventing premature collapse. Weak magnetic fields provide pressure that counteracts gravity. Guiding filamentary structures. Gas tends to flow along magnetic field lines, creating the elongated filaments where stars form. Regulating angular momentum. EM fields help redistribute rotation so that collapsing cores can condense into stars rather than fragment chaotically. Reference: Crutcher 2012, Annual Review of Astronomy and Astrophysics. Imagine a calm nebula, invisible threads of magnetism subtly sculpting the future of thousands of stars, silent but precise architects of the cosmos. On a larger scale, galaxies are filled with magnetized plasma. Here, turbulence, the chaotic motion of gas and plasma, interacts with electromagnetic fields, producing complex, dynamic structures. This magneto-hydrodynamic turbulence amplifies weak magnetic seeds into coherent galactic fields, shapes spiral arms and interstellar shocks, accelerates cosmic rays along field lines, redistributes heat and energy in the interstellar medium. Even in galaxies billions of light years away, this invisible turbulence acts like a cosmic heartbeat, slow and steady, yet shaping matter on enormous scales. Close your eyes. Imagine a galaxy's slow, swirling plasma flows, quietly vibrating with electromagnetic energy, invisible music shaping stars, dust, and gas. Finally, we reach the extremes, the most energetic EM events in the universe. Accretion disks around black holes. Gas spirals inward, heated by friction and twisted by magnetic fields. Magnetic turbulence drives jets that shoot energy at near light speed across thousands of light years. Gamma-ray bursts are brief, intense flashes of gamma rays from massive stellar collapses or neutron star mergers. They're powered by electromagnetic forces in ultra-dense plasma, converting magnetic and gravitational energy into radiation in seconds. Magnedar flares, when ultra-strong magnetic fields reconnect or rearrange, they produce sudden X-ray and gamma-ray bursts. These events release in seconds more energy than the sun emits in 100,000 years. Even in the most extreme corners of the cosmos, electromagnetic fields dominate, guiding plasma, accelerating particles, shaping jets, and sculpting the brightest explosions in the universe. From the smallest neurons in your brain to the most distant magnetars, from Earth's gentle magnetic shield to the cosmic web spanning billions of light years, electromagnetic fields quietly govern the universe. They are the unseen, silent threads weaving matter, energy, and life together. They are both gentle and extreme, subtle and immense, and they never rest.
As you lie in quiet darkness, let your mind drift with these invisible fields. Feel the slow hum of the universe around you, the gentle currents guiding every star, every atom, every thought. Sleep now in the calm knowledge that the universe is alive with electromagnetic harmony, a quiet symphony that has been playing for 13.8 billion years and will continue long after you drift into your own dreams.